Sorry, I could not unmute and I keep on talking about what is polarized light and all. So here we discuss about the topics. Yesterday I was discussing about what is ordinary ray and extraordinary ray. So how this ordinary ray helps and how this extraordinary ray helps. So in ordinary ray, the ray which is being transmitted will be flow in all the directions. That is, there is no proper propagation. It however it wants, the light can be spread. But coming to the extraordinary ray, yesterday I was discussing on extraordinary ray and ordinary ray. On the extraordinary ray, which helps to propagate the flow in one direction. That is about extraordinary ray. So the rays which are known as ordinary ray and extraordinary ray. So yesterday I was discussing on that topic. Yeah, today we are going to discuss next further topics, that is the production and analysis of different types of polarized light. So what is mean by polarized light? So before going to the depth of the polarized light, we need to the basics. We need to know what is polarization. So polarization is nothing but we uh, we are talking about polarization of the light. So E is nothing but a transverse wave. Polarization is nothing but a wave which is going in a transverse wave is nothing but a wave which is having both unpolarized and polarized. So the material which is helping to get an output without disturbances is nothing but polarized light. For example, a light wave is sent to a material. That material is nothing but a polarizer. So the light waves which are being transmitted through that lens is nothing but the output which we get is nothing but polarized light. So the polarized lens we are going to use. So the lens which are going to be used is nothing but a polarizer. So we are going to find the what is unpolarized light and what is polarized light. Unpolarized light is nothing but the light which is not being filtered. Is nothing but unpolarized light. So when that light is falling through the polarized lens or a material which is coming out is nothing but a polarized light. So there is no disturbances when it is polarized. For example, if we are taking a lens which is having the lens which is helping the light which is polarized means, for example, if you are taking a regular lenses, specs, where the polarization is done. So polarization is done in that material or in that lens or in that fiber or glass material. We say that it is polarized lens. What it does when the light falls on a glass material, when when we are driving in the night, when the light falls on the glass material, so if it is a polarized lens, the blurring or the light which is reflecting and refracting does not disturb the eye. So if it is an unpolarized lens, when it is falling on a glass material which is not polarized, it distracts and disturbs the eye. So that is what is the difference between polarized lens and unpolarized lens. So the polarization is nothing but a property um, is polarization is nothing but a property of, as I told you, it's a transverse wave which specifies the geometrical orientation of the oscillations. In the transverse wave, the direction of the oscillation is perpendicular. So what it does, the direction of the motion of the wave, in simple way, we can say that polarized transverse waves is by vibrations traveling along the string. So for example, musical instruments we are taking like a guitar string. So depending on how the string is plucked, the vibrations can be vertical direction or horizontal direction at any angle perpendicular to the string. So in such a way, it contracts the longitudinal waves such as sound waves. In liquids or gases, if we are taking, the displacement of the particles in the oscillations is always in the directions of propagation. So these waves do not exhibit any polarization. Sorry, exhibits polarization. So these are the transfer waves which helps the exhibition of the polarization. So here we can talk about electromagnetic waves such as light and radio waves, gravitational waves we can talk, and radio waves also. So which helps the sound waves in solids. So that all topics comes under the polarization. We can take many different examples. So mostly what we talk in degree level is about electromagnetic waves. How these electromagnetic waves such as light consist of a coupled oscillating electric field and a magnetic field which are always perpendicular to each other. We have to know that electric field is coming out as a wave. Perpendicular to that, magnetic field will also be perpendicular. So that is nothing but the convection of the polarization of electromagnetic waves. So which directs the electric field. So that is about the linear polarization and circular or elliptical polarization. So we are going to study different. So I'm just telling you the basics of the complete the picture of the polarization. So how this polarization is helping, how this polarization can be filtered, okay, how unpolarized lens or polarized lens difference also I told you. I also explained you now the light which is falling on a polarized material, the light waves which are unpolarized and after polarization done, how the light is coming out. So this is about the basic. So now we are going to go to the depth. That is about the detection of polarized light, plane polarized light, circularly polarized light, elliptically polarized. So these are the topics to be discussed and need to understand more about the concept, how this polarization takes place. So these are the basic terms and terminologies which we use in our polarization. So how this polarization helps to filter the filter the rays which are being propagated, and the rays which are helping not to disturb or our distract the concentration. Means when we are traveling, when a person is having with a specs, so if he's not having a proper polarized lens, which he's not using, then it disturbs a lot because the light waves which falls on a glass material, it reflects and refracts. So because of that light which is coming through the glass material and hitting his eye, if it is not polarized, it disturbs a lot. So who is having power? So who is not having power is fine, but which is having power lens who are using, it disturbs a lot. So for example, so coming to the topic, so polarization of light, we need to talk about the polarization of light, nothing but a transverse waves. Property shown by transverse waves. The light waves which travel only in a single plane are known as polarized light waves. The process of transforming unpolarized light wave to polarized light wave is called polarization of the light. So we talk about a single line now. So what is a polarized light? So polarized light is nothing but the light which is going in one direction. So unpolarized and polarized. Simple. The rays which are going in a transverse waves to the polarized lens, which are coming out, will be more crystal clear. The light waves which are coming out will be more crystal clear. So then what is, we can talk in a simple words, as I told you. So uh, we can say that, for example, if we are taking a long range along a continuum, but which is concentrated at opposite extremes, that is it. we can take that as a different polarization. Okay. Then we can say it is a monochromatic light. The polarization is nothing but a monochromatic light, which is in those days I could find in black and white. So describes about complex electric field, amplitudes and directions, and the propagation occurs in directions. Okay. So let us go to this. So this when it was being invented means I hope it is discovered in 19th century. Let's see the depth and introduction of these topics. Okay, so these are the objectives we need to discuss. Discuss production and properties of circulatory and electrically polarized light. Describe the experimental setup for the production of circulatory and electrically polarized light. Define plain polarized light, circularly polarized light, and electrically polarized light. So introduction. So what does they say? How this is going to be useful? So plain polarization is a simple type of polarization. We have learned in the last unit that is doubly refracting crystals like quartz or salicylate strips. An ordinary unpolarized beam into two components, that is ordinary and extraordinary, as I told you in the last class. So both these rays are plane or linearly polarized, but vibrational directions are mutually perpendicular. Vibrational directions are nothing but electromagnetic waves. Vibrational directions are mutually perpendicular in the sense it is having both electrically and electric field as well as magnetic field. So when electric field is a opposite to that, perpendicularly magnetic field will be produced. So this is the very basic important concept we need to understand before going to the topics. So how these vibrational directions are helping mutually perpendicular. So that is nothing but electromagnetic fields. Electromagnetic fields are nothing but an electric field is there in our nature. Perpendicular to that, magnetic field will be continuously flowing. We can take magnetic field as well as electric field. We can go with the both. So what we want, natural current, whatever we are using over here, we are taking electric field. So when there is no power, the battery supply is being given. So that is nothing but magnetic field. So when both are there, electric field as well as perpendicular, that magnetic field is continuously flowing. According to our convenience, whatever the current we need, we are taking electric field as well as magnetic field. So in the magnetic field is nothing but a battery. Battery is nothing but having both north pole and south pole. So when it's being charged, so it is going to be used for some hours. So that might be your laptops, your gadgets as well as your phones. Everything comes under the battery. So wherever the battery is being used, there will be a magnetic field, means a battery is being involved in that. So we are using both. So we are using both. So wherever electric field is there, there will be a magnetic field. So this is the main concept we need to understand how this electric field and magnetic field is helping. So the material, that is material. Why we are talking about material? Because we want to test the crystals. The crystals might be any material. That might be quartz or calcite, an ordinary unpolarized beam into two components, that is ordinary and extraordinary. Both these rays are plane or linearly polarized but bidirectional. So whenever the light falls on a material, that might be quartz or crystal, any material if you are taking, what happens? It starts vibrating and radiating. So that is nothing but a electric field will be produced as well as magnetic field will be produced when it's vibrating. So when the light falls on the such materials, we need to find out what is happening, how the things are going on, what it is reacting of the crystal. In the crystal, the materials which are going to be used, that might be, we can take hydrogen, helium, lithium, niobate, oxygen, carbon dioxide. We can take any material. We can take any particle and we can test. When the light is falling on such crystals, we are going to find how that is reacting, how that crystal is acting, how that crystal is helping to use. So that nowadays we are going to use the fiber optics. Advanced topic is about fiber optics. We are now studying about the basic optics, how these optics are going to be used, how this diffraction, coherent zones, and the plan of diffraction, um, and how these diffractions are going to split, and how this interference is taking place. Now, after diffraction, how this ordinary and extraordinary ray is acting when it is having a polarized lens, when the light is falling on that material, how these unpolarized and polarized lens are being taken when the polarized lens is falling on such material, how that vibrations are taking place. So it's a basic chain of the basic chain of the explanation that it is by step by step, it takes place. So the material presented in the previous unit clearly shows that under certain conditions, ordinary and extraordinary ray travel along the same path. So as we have discussed, ordinary ray will be there, extraordinary ray will be there. So in ordinary ray, as I told you, the ray which will be flowing however it wants. But when coming to the extraordinary, the ray which is being propagated to flow in one direction. So, ordinary and extraordinary ray travel along the same path, but with a differing speeds. So ordinary ray will be different speed and extraordinary ray will be different speed. That is what they could find. For example, consider a sunset crystal with its phase but parallel to the optic axis. Okay. Light incident normally on one of its faces transfers the crystals in a direction perpendicular to the optic axis. So axis is nothing but we can take x-axis, y-axis, and z-axis. Okay, the extraordinary and ordinary take same path, but with a different speed. So the different speeds, what we can find is nothing but a phase difference, and we can find the speed also. Difference what we can find from the ordinary as well as extraordinary. So how the ordinary ray will be traveling, how the extraordinary ray will be traveling. As they emerge out of the crystal, the two rays develop a phase difference. Yes, that is what is very important. So what we are going to find the difference is nothing but from ordinary ray to the extraordinary ray. The frequency will be the same. Um, the frequency wavelength will be the same, but the difference is the speed. Nothing but phase difference. We can find the different speed. We can find the phase difference between them. This phase the difference depends on the frequency of the incident light, thickness of the crystal, and the speed of the two rays. How the crystal of that and as well as the speed of the two rays. Okay. Here, given a best introduction, very interesting. So, superposition of the two rays after emergences from the crystal leads to interesting results. So, the problem reduces to one of combination of two simple harmonic functions in mutually perpendicular directions. So, two mutually perpendicular directions means we know that which is going having both the electrical as well as magnetic. So we know that superposition of two simple harmonic functions at right angle leads to different shapes I am sure. Okay, the phase difference, that is what we can find the difference between two waves is nothing but phase difference, that is 0, 2 pi or any other even multiple of pi. The result is a linear vibration at 45 degrees to both the original vibrations. When the phase difference in an odd multiple of pi, the resultant is again a linear vibration but at right angles to the previous one. So, a phase difference of n pi by 2, that is n is equal to 1357, leads to a circle. At all other phase differences, the result is an ellipse. So, here we can find the phase differences and how the simple combination of the simple harmonic motions at the right angles. So, here we can see that there is 0, say then pi by 4, this, then pi by 2, 3 pi by 4, pi. So we can find the different angles. That is nothing but in ellipse. So what do we mean by circularly polarized light, electrically polarized light, by the light vibration? We mean the periodic vibrations of the electric field in space, which is there in the space. Okay, hence in a circulatory polarized light beam, the tip of the electric vector moves in a circular, in a plane, perpendicular to the directions of the property. So how the light is falling according to the direction, according to the propagation, the we can see the structures or we can see the ellipse of the phases and we can find the phase difference of that wave. Similarly, the tip of the electric vector moves in an ellipse in a polarized light. Very nice. So that is next is quarter wave rate. So what is we are finding for the quarter wave plane. So when the ordinary and extraordinary rays transfers the same path in crystals with different speeds, the distance traveled by them during a particular in travel of time difference, they develop a path by phase difference. If the thickness of the plate is so chosen, so to introduce a path difference is nothing but lambda by 4. So we are taking 4 waves. That is lambda is nothing but wavelength of an instant light. So the crystal plate is called quarter wave plate. So we have also half wave plate which introduces a path difference of lambda by 2 and full wave plates which introduce a path difference of wave wavelength, that is lambda. So in wave propagation, a path difference of lambda is nothing but wavelength corresponds to a phase difference of 2 pi. Hence, a quartz wave plate introduces a phase difference of pi by 2. So we need to understand the depth of this concept. So how these calculations are taking place, how this is being helpful. So in wave propagation, a path difference of wavelength corresponds to a phase difference of 2 pi. Hence, a quarter wave plate introduces yeah. So here we are calculating the thickness of a quarter wave plate. As mentioned earlier, thickness depends on the wavelength. If mu naught and mu e is nothing but ordinary and extraordinary refractive indices of the material chosen at T, the thickness of the crystal plate, the optical path difference, that is delta is given by. So nothing but what we are going to find is pi differentials. So here delta is equals to ordinary minus extraordinary of T. So for a quarter wave plate made out of a negative crystals like salcite, that is mu naught minus mu e of P naught, which is equals to lambda by 4. That is wavelength That is wavelength by 4 waves. That is 1, 2, 3, 4 waves we are taking. So we are calculating for four waves, four transverse waves. Okay, so then it is happening T of H, that is lambda by 4 of mu naught minus mu e is nothing but ordinary and extraordinary. For positive crystals like quartz, that is T of H is equal to lambda by 2 mu naught minus mu e. So here we are going to for negative crystals as well as positive crystals. We can find both. We can find both the ways, that is positive. This will be the positive ways. This will be the negative ways. How we can find positive and negative is because of the axis, x-axis, y-axis, and z-axis. So if it is having a positive axis, x-axis positive, x-axis negative. So that is the depth of the crystal. So for negative crystals, for positive crystals. So one for the complete crystal, one inside the particle we are talking about. So if we are taking for the whole crystal, we can take for negative crystal as well as for positive crystal. So we are for that crystal, we are taking four wavelengths. Yeah, I'm just checking the topics. What else are the topics? So tomorrow will be the last class. So by tomorrow, I want to wind up the whole topics which we have discussed and covered till now. So I'm just checking out what are the other topics to be discussed also. Rotatory polarization, net Fresnel expansion or rotatory polarization. Okay. Optical activity. Nice. Then Fresnel expansion of rotatory polarization. Okay. Nice. This is also good. What will be the next topic? Polarimeter. With the polarimeter, it consists of the polarizer and analyzer mounted on a graduated scale. Okay. Okay, these are the topics to be discussed and okay, next will be. So this topics all is about polarization. So how this polarization is taking place, how this polarization helps to. Okay, next is lasers and holography. So laser holography. Introduction to fiber optics. Awesome. These topics are very awesome, very nice. Complete information how this can be advanced, we can use what it have given. Very nice. Laser. Obviously, lasers are connecting. So tomorrow I will be discussing on lasers and holography and fiber optics. Because after polarization, next level is about fiber. So how this fiber optics is helping to use this lasing actions and understanding. After that, we check and any experiments. Application of the brain source. Okay, we'll go tomorrow with these three topics. That is the last two topics because polarization, the basic concept, how this polarization is calculated, how this polarization can be calculated by if you are taking say circular motion or elliptical motion, how the circular motion can be calculated by inch also we can calculate. So next topic will be tomorrow we need to discuss these three units, these three topics which are very important and that is advanced technology. Okay, it is about laser, sorry, fiber optics, holographic everywhere. The last topic is about fiber optics. Introduction to fiber. Okay, they have just introduction to fiber optics. Okay, we are going to stress much on lasers and holography. And unit 12 is about the introduction to fiber optics. I don't find any. This 7 is there. Going to it wrong. Okay, that is no chapter of 12. How to discuss. Okay, let me check some other. Okay, today we will wind up with this polarization. So polarization is nothing but if we have both ordinary and extraordinary, right? So how this polarization is helping. Then yesterday we have done this. Today we are discussing about 8th and 9th unit. Yeah. Okay, so if a beam of a plane focused light is incident on the faces of A to C, it gets splits up into two circularly polarized components. On striking the inclined surface that is C to B, and entering the second prism, the disturbances which passed through the first prism now becomes slower. Hence, according to the law of refraction, one beam is bent away from the normal and the other towards it. Since at other inclined faces, similar effects takes place, the two beams get separated as they emerge from the crystals. This was actually observed by Fresnel. So now we need to know about the polarimeter. Before topics about the polarization, everything was discussed about how this elliptical, circular, how this elliptical can be calculated, how the circular motion can be calculated. So this all can be done with the experimental and we are able to find the ordinary and extraordinary ray. When the ordinary ray is forming on a crystal, how that ray is going and when the extraordinary ray is going. So what is the difference between the ordinary ray and extraordinary ray? How the rays phase difference and what is the speed of the. So ordinary ray obviously it flows very faster than an extraordinary ray. So polarimeter, we are going to use this polarimeter. So this is the instrument that measures the rotation of the plane of vibrations are called polarimeter. So the instruments intended for measurements on sugar solutions in particular are called Saturimeters. A polarimeter in its simplest form consists of a polarizers and an analyzers as shown in the figure. So the analyzer is mounted on a graduated scale. So this is the scale we can find out lens M2T and M2 on here. So initially the analyzers, the polarizers are adjusted to be in the crossed position. The reading of the analyzers is noted. The active substance is now introduced in between the polarizer and the analyzer. What is polarizer and what is analyzer? Polarizer is nothing but the the light which is falling on a polarized lens and how it is polarized with the ordinary and extraordinary ray. How the ray, if it is the ray which is again that rays which is falling on the crystal material, that crystal material how it is reacting, how the action is taking place, that we are going to find. So analyzer is nothing but we are going to analyze the polarizer and analyzer is nothing but we are going to analyze how this rays are going and how this can be uh, how we can analyze it by extinguishing the light coming off it. So the reading is noted. The difference between the two readings of the analyzers gives a rotation. So with a simple system, the intensity of the field of view is very insensitive to small rotations of the analyzer from the positions of extinctions. Consequently, the analyzer cannot be set with accuracy. The performance of the simple systems may be improved by using half shadow endpoint devices immediately after the polarizer. Such a device enables accurate determinations of the extinction positions as it compares intensities of two halves of the field of the wave, that is laser and detector. We can see how this laser is helping, how the detector is finding. Okay, P quartz is one such half shadow device. It consists of two semicircular quartz devices cemented together. One half is connected from right-handed quartz and the other from the left-handed quartz. The thickness of the disc is 3.75 mm in such that for yellow light, the plane of vibrations undergoes and rotations of 5 clockwise in one half of the disk and anti-clockwise in the other. Thus, for yellow light, the biquartz consists of two quartz wavelets with which with white light and the rotatory dispersions. Dispersions of the quartz causes the vibration directly. So ultimately, we are going to find the light how it is vibrating and leaving. The whole concept talks about vibrations and how vibrating and radiating. So with this different colors, we can find the rotations of the analysis causes one half of the peak to become distinctly red and other to become blue. The settings of the analyzer for a color match can be done very accurately. So what is the summary? The phenomena of rotation of vibration is being polarized about the directions of propagation exhibited by certain substances like quartz. So the solution is called optical activity. The amount of rotations in each direction directly proportional to the length of the path in the optically active substance and inversely proportional to the square of the wavelength. The rotation is clockwise. The substance is said to be extraordinary. Extraordinary. If the rotation is anti-clockwise, the substance is said to be laboratory. The specific rotation of a solution is defined as a amount of rotation produced by one decimeter length of solution when the concentration is 1 gram per cc. So polarimeter is used to determine the angle of rotation produced by optically active substance. The precision, the precision of measurement of angle of rotation produced by optically active substances by using a light points. Right. So this is all about how this is being seen and all about the polarization. Next, tomorrow topic we will be discussing about laser and photography. How this laser is used. So let us see the introduction. I am enthusiastic to see this introduction about laser. So these are the topics we are going to discuss tomorrow about laser. So introductions are very interesting. So man is continuous efforts for understanding the nature of the light, found it to be an electromagnetic wave and duality, particle nature and wave nature. During the last part of the 19th century, these discoveries opened new vistas in the constructions of various sources of radiation, not only in the visible region, but in the region below the beyond the visible regions. Yes. Of the electromagnetic spectrum also. In 1916, Myman succeeded in producing a beam of pure red light of high intensity, uh, concurrent and monochromatic, the invention which was called laser. Okay, is very much different from the generators of light used in that time. So laser is an acronym for light amplification by stimulated emissions of radiations. Light sources such as tungsten bulbs, fluorescent lamps, and even the so-called monochromatic source like sodium lamps produce a wide band of frequencies with no tolerance. Okay. No coherence in measurements of having any differences, phase differences. While the laser beam is highly monochromatic, coherent and intense as well. Today, the laser has become an indispensable tool in the fields of physics, biology, medicine, chemistry, and in industry. Yes, this laser which helped to vastly develop in physics, biology, medicine, and in industry. That's absolutely. So next topic will be emission and absorption of radiation. Very interesting, as well as how it emission takes place, how it absorbs. So the radiation which is falling through the phone or through the tower, everything comes under radiation. Because why the radiation takes place? Because in natural phenomena also there is electric field. So the radiation also comes from the sun. Why? Because through the sun also electric field and magnetic field is produced. Because of the sun, we get a vibration, which is being produced with the radiation. Means where our body also has electric field as well as magnetic field. So because of that radiation, we get heated up. We get sunstroke. We get headache. Because why? Because the radiation is taking place much. So, in such a way, we are taking natural phenomena of the radiation was there that we can observe and we can have the emission also. So, when coming to the physics topic, that is emission and absorption of radiation. So, why this radiation takes place? How this radiation takes place? How these electrons are vibrating and re-radiating, and how this energy will be transmitted, why the phones are getting heated up, why the laptops are getting heated up, why the towers, they say that we should not be near to the tower of the phone signal because lot of radiation will be produced from the tower. So it gets heated up. The more absorption, the more heat will be produced. That's why all the laptops, all the desktops, why it is being centralized? Because it gets heated. Too much of radiation. To make it that gadget smooth, every software company will be centralized because of the too much of radiation. So here we are going to talk about emission and absorption of radiation. Tomorrow I will discuss about this emission and absorption of radiation. So how this emission takes place, how this absorption takes place. So excitation by absorption, de-excitation by emission. Next will be the spontaneous and stimulated emissions of radiation. How the spontaneously, how it works. So wave of amplitude and wave of amplitude A and wave of amplitude B different and wave amplitudes, right? So we are going to take both first wave, second wave, and resultant wave also waves superposition. So we are talking how the radiations are taking how the radiation is taking place, how the wave is being producing continuous the radiation. So next will be the fluorescence and phosphorescence. Interesting topics. We will try to complete it as early as possible. So tomorrow is the last class, and tomorrow I am going to discuss all these topics about the laser, holography, and the fiber optics. So fiber optic topics are not going to back. So we will discuss both these topics, how this takes place, how this can be, how it works. So that we are talking now, till now we have discussed about all the topics about the optics, interference, coherence, diffraction, how the Huygens principle used, that is wave theory, how the Frenzel and Fraunhofer diffraction takes place. We have two different diffractions, that is Frenzel and Fraunhofer. So they could explain much in depth about the how these rays are being produced, which is ordinary and extraordinary, how these ordinary rays will be produced and how the extraordinary rays will be produced. So next, we have discussed about polarization also, how this polarization of light is helping to find out. So next, the last topic which we are discussing tomorrow is about laser and photography. So with that, tomorrow's class, we can come. We have completed the whole syllabus, whole topics. Okay, then see you all tomorrow.